Hi everyone, welcome to Vignan University. So today my topic is integration. So in this lecture, in my lecture, you will be able to understand the concept and rules of integration and then evaluate some simple integration. So before going for the integration, I'll give a very good example for you. It means how the general problem can be related to integration. Let us see. Let us say you make 10 rupees per day. How much money you will make in 10 days? That is my question. So, 1 day 10 rupees. 10 days 100 rupees. Very simple. I want to represent this in terms of integration. Just see, since you made 10 rupees every day, if day changes, the money you make change. Is it clear? See how they come out to be the same. What I'll do, integration over 0 to 10, 10 into dx. What is changing? Day is changing. From 0 to 10. So x is the variable which is changing, x is nothing but your day. What is fixed? Your earning is fixed per day, that is nothing but your 10 rupees. So that is what I have done, 10 into dx. 0 to 10 equal to integration of dx is how much? X. 10 is a constant. I keep as it. Right? So 10x. And your limit is 0 to 10. This is called lower limit. This is your upper limit. So what you will do? 10 into upper limit, 10 into 10 minus 10 into lower limit, 10 into 0 equal to 100. We got it? So the same type of problem we represented in integration, right? So integration is easy. I don't feel it's difficult. Yeah, let us see. Let us go to the main topic. What is integration? How you are going to apply it? How can you evaluate all these things? I will explain very clearly. See this. For example, I have given integration over 2x equal to x square plus c. I think you know this one. I think you know it, right? Integration of 2x dx is equal to what? 2 into x square by 2 equal to x square. So, x square plus c. The c is called integrating constant. This symbol we call it as the integral sign. And this one we call it as the integrand. We call it as integrand. This, I think you are all aware of it. Just I am refreshing you. So, this part we call it as your integrand. Right? That is your integral sign, and this is nothing but your integrating constant, which is a very important thing. If you forget plus c, then it will give a lot of trouble to you. Right? Let us see. Integration as differentiation in reverse. Integration and differentiation both are just like two sides of the coin. Two sides of coin. Right? They are all attached to each other. Integration as differentiation in reverse. See here. Derivative of x cube into dx is how much? 3x square. And integration of 3x square dx is how much? X cube with a constant t. Constant c may be 0, maybe 3, maybe 100. That is why we are writing c. This is the arbitrary constant. Right? So, differentiation, integration, just both are opposite. If a function will have a differentiation or if perceive a antiderivative, then only it is possible for evaluating the integration for it. So they are just opposite to each other, right? Yeah. The situation is just a little more complicated. Why? Why I want to say this? Because, see now, dy dx of x cube plus 10, 3x square. Dy dx of x cube plus 100, 3x square. Dy dx of x cube plus 1000, 3x square. For any function, you are getting the same value, right? Even though these constants are different. So, this constant doesn't matter because derivative of a constant is always 0. So, when you go reversely, what happens? This 10, 100, 1000 become constant. Is it clear? And this function will be fixed. Is it clear? Right? So, that is the importance of the c when you do the integration. All these functions of the same derivative because when you differentiate the constant term, we obtain 0. Consequently, when we reverse the process, when we reverse the process, just process of integration, we have no idea what the original constant is, whether it is 10, whether it is 100, or what is 1000. So, we include in our answer an unknown constant, we call it as C. We call it as C. And this is called constant of integration. I think you are very clear why we are adding a constant during the integration. We know you have to always add a constant, but what is the purpose? What is the purpose of it? Why we are adding a constant into that? This is the story behind it, right? So now see, what is the basic concept of integration? When a function f of x is known, we can easily find out the differentiation of it. F of x is given. What is the differentiation of it? dy dx of f of x. df by dx. The reverse process is to obtain the function fx, from where if df by dx is given, we need to find the f of x from the knowledge of its derivative. It means derivative is given, we need to find the f of x. That process we call it as the integration. So, we will find the f of x from the given derivative is nothing but the integration. In that way we can, if you remember it, right, you can understand very clearly. So, integration is nothing but antiderivative. Clear? Right. If derivative of function f of x is 3x square, find f of x. Derivative is given, we are going to find the function f of x. Derivative of f of x is 3x square. So, f of x is how? 3x square into dx. Divide, already you know, integration of x square is nothing but x cube by 3. 3 is multiplied here. So, 3x cube by 3 plus c equal to x cube plus c. Right? We have added a constant, remember it. What is definite integral? What I said previously, we are adding one arbitrary constant. We are integrating constant there, right? So, that constant is indefinite, whether it is 100, whether it is 10, or whether it is 1000, right? That is why we call it as indefinite integral. But here, I am talking about definite integral. It will have definite value and it will not contain any integrating constant. That is the difference. Definite integral is so called like this because it is definite value. It gives a definite value. Integration of a to b f of x dx is called the definite integral, right? From a to b, where a is nothing but your lower limit, b is nothing but your upper limit, right? So we define like this: a to b f of x dx equal to fx at b minus fx at a. Upper limit minus lower limit. The function f of x at upper limit minus the function f of x at lower limit, where fx, capital F of x, is nothing but the integration of this f of x, right? Remember it. So this fx, the fx is different. So f at b minus f at a. This is nothing but your definite integral. So the main challenge is to recognize which technique or formula to use to solve a given problem. We have varieties of formula in differentiation as well as integration. So which formula is suitable for which problem? It's a challenge. That is why we confuse every time. This problem is there. What formula I need to use it? Is it clear? So I'll give some tips that based by seeing that function itself, by seeing the problem itself, how can you judge that this formula is suitable for this? I will give different tips, right, how to proceed it. The first technique is some basic formula should be memorized. Basic formula should be memorized. That is very important thing, right? Wow. So, what is the basic formulas? Just I am noting down. Already you know this. Integration of x to the power n dx equal to x to the power n plus 1 by n plus 1, where s is not equal to 1. I have written in the bracket. Why? Because when n equal to 1, what happens? There is some problem, right? Yeah. Integration of e to the power x dx. Here n is not equal to minus 1, right? N is not equal to minus 1. Because when n equal to minus 1, then what happens here? Yeah, it becomes 0. So here it is n is not equal to minus 1. N is not equal to minus 1. Is it clear? This is a printing mistake, right? N is not equal to minus 1. Then what? It becomes 0. And something by 0 is undefined. Okay? Integration of 1, that leads to this. So when x is minus 1, it becomes 1 by x dx equal to log x. Integration of e to the exponential function dx equal to e to the power x. For integration of a to the power x dx equal to a to the power x by log a. Sin x, secant square x. These are already, you know the formula, right? Secant x tan x dx equal to secant x. These are the formula you need to remember. These are the basic formula. From that we can derive the different formula by using the different method like substitution and all these things, right? So tan x into sin hyperbolic x dx by x square plus a square equal to 1 by a tan inverse x cot x cos hyperbolic x, right? So these are the basic formula we should remember before proceeding for our solving. Once we arm with all this formula, right? Once we learn everything, this type of this formula, basic formulas, then we should go. How? Simplify the integrand if possible. First of all, we should see that whatever the function or whatever the integrand they have given to integrate, whether it is a complex or simple. So first of all, we need to simplify. I'll give some example how to simplify it. Look for a substitution, whether there is any substitution methods are available or not to simplifying process. Classify the integrand according to its form, whether it is exponential, whether it is trigonometric, what type of function is given. Based on that, we need to classify it. These are the three methods. When you're dealing with the trigonometric function, the variable x must always be measured in radians, not in degrees. This you must remember it, right? When you deal with trigonometric function for integration, when you are integration of sin x, what is x there? X is not degree, that is in radian form. Always remember, this is very important. For x equal to n is valid, where integration over x to the power n dx is equals to what? X to the power n plus 1 by n plus 1. So this n is not equal to minus 1. Yes or no? Right? For x equal to n is valid for any value of n except n equal to minus 1. Because it gives infinite, undefined. Right? Okay. For example, see, integration of x to the power 7 dx. How much? X to the power 8 by 8 plus c. Integration of cos 5x dx. How do you get cos 5x dx equal to how much? Sin 5x by 5 plus c. Very simple. We are just using the formula what I told previously. Simplify the integrand. How do you simplify the integrand? Just see the example that I have given. Integration of root x into 1 plus root x. Looking very complicated. Yes or no? What you do? Multiply this. Root x plus x. Root x plus x. So if you think why I am telling it is, some people what do they do? You think this is u and this is v. Two functions are there. Multiply it is become very, very complications. Is it clear? No, all people are not equal. You may think in different way. Some other people think in a different way. So first thing you try to think that we must simplify. The first thing, integrand must be simplified. So that is just simply you multiply it. So now this is x to the power 1 by 2 and this is your x to the power 1. So happily we can integrate it. Is it clear? That is nothing but the simplify. Now see the second problem. Tan theta by secant square theta into d theta. What do you do here? Tan theta I have written sin theta by cos theta. Right? Secant square theta I can write by cos square theta. Secant square theta equal to what? 1 by cos square theta. Right? 1 by cos square theta. It goes top, so cos square theta into d theta. Is it clear? 1 cos theta will cancel here. So sin theta into cos theta I can write. Now if I multiply 2 here and here 2 and here, yes, 1 by 2. Then what will happen? 2 sin theta cos theta is how much? Sin 2 theta. So 1 by 2 integration of sin 2 theta d theta. Integration of sin 2 theta d theta is how much? Yeah? Integration of sin n theta is how much? You know it? You can happily do the problem if you simplify it properly. So this is nothing but your simplify the integrand of the given problem. Is it clear? This is one. See here, another example. Sin x plus cos x whole square is there. How do you do this? You just open the bracket. Sin square x, a plus b whole square. A plus b whole square. So a square plus 2ab plus b square into dx. So sin square x plus cos square x gives you 1. 2 sin x cos x is nothing but how much? Sin 2x. Yes or no? Sin 2x. So happily we can do the integration. This process, though, first of all, we should simplify the integrand given in the problem. Is it clear? Right. Second one. Look for a substitution. Look for a substitution. Look for a substitution. Right? So integration over x by x square minus 1 dx. What you will substitute? How you will substitute? See here. In this integral, notice that if u equal to x square minus 1, then du equal to 2x dx. So you see, derivative of x square minus 1 is how much? 2x. Derivative of x square minus 1 is dx. 2x. So it is there on the top. X is there. So constant is not a matter. If I multiply 2 here, right, then it will become. So integration over, yeah, you can do it happily. 2x by x square. This is nothing but your method of substitution. See always that whether there is a possibility of any substitution in that or not. This is the second method of doing it. Is it clear? So instead of going for, why I am telling, instead of going for partial fraction, you can go, some people you can go for partial fraction. X square minus 1. So you can do x minus 1 into x plus 1. So x by x minus 1, x by x plus 1, it gives a partial fraction also. But it gives complicated. So that is why go for a substitution whenever there is a need. Classify the form and use integration by parts. This is the third approach of solving integration. When step 1 and step 2 have not led to the solution, we take a look at this. What is it? Whether it is trigonometric function or not, whether it is logarithmic function, whether I can use integration by parts or not. That is important thing. If it is trigonometric function, both are trigonometric function, you can do happily by using the first process. Logarithmic function, if and sine function is there, then it will become again another problem. So if it is only logarithmic function, then what you have to use? Integration of log x. How can you do this? Think of it, right? I think you know it. You are using integration by parts. So now think about the integration by parts. How will do it? See, I have written like this: integration of u v into dv. There are two different functions. So first function into integral of second function minus integration over integration of second function into derivative of first function. I have written very clearly by giving the function itself. But you will learn in terms of u and v. Right? So you can consider this is the first function. You can consider this is the second function if it sometimes, but it is not possible. Right? So you need to choose this first function and second function properly. How do you choose? You should choose the first function in such a way that the derivative must be go reducing. Is it clear? Let us take you choose e to the power x as first function. What will happen? Derivative of e to the power x is how much? E to the power x. Again your derivative e to the power x. It will never be 0. So you cannot solve the problem. Right? Let us take x into e to the power x is there. Integration of x into e to the power x dx. Right? How will you do this? Yeah. Which is the first function? Which is the second function? If you choose this one as the first function, then gone. You cannot find the problem. Right? So you need to choose the first function and second function properly. So x into e to the power x dx. If you choose it is a first function, then it is quite impossible to do it. Is it clear? So this is your first function. This is second function is wrong. So first function should be always this one, so that you can do. That is why I am telling you first function into second function. You should choose properly. Right? Evaluate x sin x dx. How do you evaluate x sin x dx? So derivative of x is 1. Derivative again 1 is 0. That is why this must be your first function. Is it clear? So first function into integral of second function minus integral of second function, right, into derivative of first function. This is the procedure. Is it clear? So like that you should do it. Okay? So that this d of x equal to how much? 1. So integration of sin x into dx. Like that it should be done. This is the way. So you should choose the first function and second function properly. Is it clear? Right. Integration of sin x is how much? Yes. Derivative of sin x is how much? Cos x. Integration of cos x is how much? Sin x. Is it clear? These are just opposite of it. You know this. I don't want to do, right? This is the process you need to follow right, based on the integration by parts. Manipulate the integral. This is the another one. You have to manipulate. Manipulation is wrong. You told me last class. You might be thinking like this. Manipulation means what you will do? You should manipulate in such a way that their originality should not alter. 1 by 1 minus cos x. Doing direct integration to this integrand is a little tough. So that is what we will do. We multiply this 1 plus cos x into 1 plus cos x divided by 1 plus cos x. So 1 plus cos x, 1 minus cos x into 1 plus cos x is 1 minus cos square x. Right? Equal to integration of 1 plus cos x by 1 minus cos square is how much? Sin square x. 1 by sin square x plus cos x by sin square x. 1 by sin square x is how much? Cosecant square x. Right? Plus cos x by sin square x dx. Right? Is it clear? So now you can complete this one easily. Cos x by sin square x and cosine square. This is the substitution. By the substitution you can put here, right? You can take sin x is equals to t and cos x dx is equals to dt. The first process, method of substitution you can use and you can evaluate the integration easily. Integration of cosecant square is how much? Minus cot x, right? So minus cot x plus this, you do the integration by the substitution, you will get the answer for AP. So this is what we have done. We have manipulated the integrand by multiplying a term which cannot alter, which should not alter the function given. This is very important thing. So if you are multiplying 2 here, you have to multiply 2 here. What are the functions you are multiplying above? You should multiplying below also. Right? This is the manipulating the integrand. Right. See here. I have given another example. Integration of e to the power root x dx. Here what we will do? So what you do? Put x equal to u square. So dx equal to 2u du. Directly you cannot integrate it. So what should you do? X equal to u square. So dx equal to 2u du. Put there. What you will get? Integration over e to the power root x. So e to the power root x. X equal to u square. So root x equal to how much? U. Right? And dx equal to how much? 2u into du. Right? So what you got now? This can mean 2 into integration of u into e to the power u du. Is it clear? And this is nothing but 2 into u into e to the power u minus e to the power u plus c. Is it clear? What we have used here? Integration by parts. Integration by parts. Is it clear? So this is what you need to do it. So what we have done? We have substituted, proper substitution is done, and we have applied integration by parts. This is the way we need to do it. Let us see here. Integration of dx by x, root over of log x is there. So what do you do? Substitute u equal to log x. Because its differential is 1 by x. Derivative of log x is how much? 1 by x. Already it is given. Already it is there in the problem. So that is why it will be very easy for us to evaluate it. This is the substitution. So we need to judge the given function properly. Then which method we need to use it, we have to think of it. So instead of solving or remembering the problem, we should remember the method what we are learning. What method we need to put in that particular problem so that we can easily solve it. That you must concentrate it. So instead of mugging up the problem with answer, we should remember certain basic formulas. Then we should remember some tips. Based on that, you can solve any type of problem. Is it clear? That is what I wanted to say you. I don't want to solve the whole problem, everything here. I am just giving you the tips that how can you attack the problem, unknown problem. That is very important thing. Is it clear now? You understood how to do this? That's what I wanted to say. Now the question arises. Will our strategy, whatever the strategy I have told you now to attack a particular problem, enable us to find the integral of every continuous function? Is it possible? For example, I have given integration of e to the power x square dx. Solve this one, right? And message me, mail me the answer for it. Integration of e to the power x square dx. How can you do this one? Right? Is it possible to do the problem by the method what we have learned now? Right? The answer is no. At least we cannot do it in terms of the function what we learn or what we familiar with till now. It may be possible in the further, but now what we have done in that particular process, it is quite impossible to solve it. In fact, the majority of elementary functions don't have elementary antiderivative. So this is an elementary function. The elementary function which possesses a derivative, right, but do not possess an antiderivative. Then we cannot evaluate that particular integration. Is it clear? So that is what I wanted to say. So every function, it is not possible to integrate by using this method. This is called what? This is your true method, or this is your analytical procedure. Analytical procedure, every function cannot be integrated. So what are the different applications we have? So integration may be applied in many places, right? Area between the curves. If two area, this is how do you find out this area? You can easily find out this. But if this is like this, then how do you integrate this? We have to use the integration. Is it clear? So this you can easily, if this is a square, you can find the area of it easily. But the irregular shape, then what you do? You have to use the integration for it. Distance, velocity, acceleration, how to find the volume, average value of a function, right? Work done by the force, center of mass, kinetic energy, improper integral. What is improper integral? We will discuss when we will come to the class. Probability, arc length, surface area. These are the different places where integration can be used, right? So this application part, right, we will discuss in another class, right? But what I told today, the tips or the method you follow to attack a particular problem. Not that we should remember the problem and the answer. We should remember the tips, we should remember the basic formula, and we should remember the path, the way, right, the strategy to solve the problem, right? That's what I understand. I feel you understood clearly, right? So, thank you very much for your patience.